always remember, if you will configure OSPF on this router first, right? Guys, this router will wait for 40 seconds for DR and BDR election. If within 40 seconds you will configure OSPF on this router and this router, right? Definitely this router will become DR. But within 40 seconds, if you will not configure OSPF on this router and on this router, right? This router will elected as DR. Right? So once you will configure OSPF on any router, that router will wait for 40 seconds for the DR and BDR election. Router will wait for 40 seconds only. Within 40 seconds, if this router will not receive any hello message with higher router ID, this router will declare that I am DR in network. In the same way, in a class, if there is only one person, right, then definitely they will become monitor, because there is no one. So router will wait for 40 seconds for DR and BDR election. 40 seconds only. So first, if you want to make this router as a DR, first we need to configure OSPF on this router, then on this router, then on this router. Or within 40 seconds, if you can configure OSPF on this all router, then it's fine. This router will become DR. Let me start. Okay, so recording is fine. Here you can see in this topology, router ID of this router is 2.2.2, router ID of this router is 4.4.4.4/32. I am going to configure this network, right? And first of all, I will configure OSPF on R1. And I will show you R1 will wait for 40 seconds for DR election, right? This router will wait for 40 seconds only. That within 40 seconds, if this router will receive any hello message with higher router ID, then this router will declare their self as DR other. Okay? So see, go to R1. R1. First of all, let me configure IP address. So guys, here in this multi-access network, I am going to run this IP address 192.168.10.1. So here on this interface, I will run 10.1, on this interface 10.2, on this interface 10.3, and on this interface 10.4. Okay? So go to R1. Interface fast Ethernet 0/0, no shutdown, IP address 192.168.10.1, 255.255.255.255.0, exit interface loopback 1, IP address is 1.1.1.1, 255.255.255.255. Fine. So interface fast Ethernet 0/0. Wait. Okay, let me configure OSPF. Router, OSPF, and process ID. Process ID is locally significant. Process ID can be different as well, right? So network is, suppose network is 0.0.0 and wildcard mask is 255.255.255.255 and area is 0. So IP interface fast Ethernet 0/0. So this interface is join the multicast group. So IP OSPF interface fast Ethernet 0/0. Okay, let me disable OSPF, no router OSPF, and process ID is 100. Let me configure OSPF again. Router OSPF 1 and network is 0.0.0. Wildcard mask is 255.255.255.255 and area is 0. So IP OSPF interface fast Ethernet 0/0. Now guys, you can see designated, no designated router, and state of this interface is waiting. This router will wait for 40 seconds, right? After 40 seconds, if this router will not receive any hello message from neighbor, this router will declare this interface as DR. Now it's waiting. Just wait. See, who is DR? 1.1.1. Now this router is saying that I am DR. Right? So after 40 seconds, router will declare their self as DR. If within 40 seconds, router will not receive any hello message with higher router ID. Right? And if I will configure OSPF on router 2 now, I am going to configure OSPF on router 2. See, first of all, let me configure IP interface fast Ethernet 0/0, no shutdown. IP address is 192.168.10.2 255.255.255.0. Now exit interface loopback 1 and IP address is 2.2.2.2 255.255.255.255. Exit router OSPF process ID 1 and network is 0.0.0. Subnet wildcard mask is 255.255.255 and area is 0. So IP OSPF interface fast Ethernet 0/0. Now this router is BDR, not DR. See, router ID of R2 is 2.2.2. Router ID of R1 is 1.1.1. Still 1.1.1 is my DR. You can see who is DR 1.1.1.1 and who is BDR 2.2.2.2. So if you will configure OSPF in this network, you should start configuring OSPF from R4. Right? You will configure OSPF on that router first. That you want to, if you want to make this router as DR, or if you want to make this router as DR. So first you need to configure OSPF on that router, right? On this router. I want to make this router as DR. So first of all, I will configure OSPF on this router, right? First I will configure OSPF on this router, then I want to make this router BDR. So then within 40 seconds, I will configure OSPF on this router, right? So now if I will configure OSPF on R3, do you think that this router will become DR? Once a router will elected as DR, guys, they will not change their role till you will run clear IP OSPF command, clear IP OSPF process command, right? Let me configure R3 as well. Interface fast Ethernet 0/0, no shutdown. Say no shutdown, and IP address is 192.168.10.3 255.255.255.0. Exit interface loopback 1. IP address is 3.3.3.3 255.255.255.255. Exit router OSPF process.
And we also advertise it like 192.168.10.0 and 0.0.0.255.
Network command.
Yes.
Yes.
192.168.10.0 and 0.0.0.255. 3 times 0 and 255.
Exactly. In the real time, you will run this command. You will never run 0.0.0 command, right? In the real scenario, your one router, maybe this interface, on this interface you are running OSPF, and on other interface you are running BGP or ISIS, right? So you will never run 0.0.0 command in real time. And how I will advertise loopback? Network 3.3.3.3, wildcard mask 0.0.0 and area 0. So
this is the correct way. I think we should configure like this only, because otherwise when we will see this video again after finishing classes, then there will be some confusion.
Yes, you should practice like this. Actually, I am configuring 0.0.0 to reduce time only. Okay.
It will take the same amount of time.
Okay.
We need to change the digits.
Remember, till after now, I will not advertise 0.0.0 command. Okay. So you have to also run particular network. You have to advertise. You should also advertise particular network. Okay. And now you can see this interface is not DR and not BR. Who is DR? 1.1.1 and who is BDR? 2.2.2. Now I want to make this router as DR. This router as DR. What I need to do? Go to R1 and run clear IP OSPF process. Yes. So IP OSPF interface fast Ethernet 0/0. Now you can see no designated router. Okay. Who is designated router? Who is DR? 2.2.2. And now who is BDR?
We need to do same thing on router 2 also in order to make router
yes.
DR.
Okay. On router 2, clear IP OSPF process. Say yes. So IP OSPF interface fast Ethernet 0/0. No DR. Just wait. No DR. No DR.
So we know even if interface is up.
Yes, interface is up, and now so IP OSPF interface fast Ethernet 0/0. Now you can see who is DR. 3.3.3 and who is BDR? 4.4.4. Right? Sorry, who is BDR? 2.2.2. On router 2 you can see.
So whenever DR others sends the update, it will send on the multicast address 0.6, right?
When DR other will send update to DR,
then it will use .6.
yes.
And when DR flood multicast update to DR others, it will use .5.
Exactly. So DR5 will listen by DR other, and .6 will listen by
DR and BDR.
Yes. So now this router is DR other. So this interface is member of 5 only, .5 only. right? You can see on router 1. So IP interface fast Ethernet 0/0. This interface join this multicast group only, right? But if you will run same command on R3, so IP interface fast Ethernet 0/0, you can see this interface join two multicast group, .5 also and .6 also. So DR will listen on both, on 5 also and 6 also, but DR other will listen only .5. Okay, now let me configure R4 first. Go to R4. Configure terminal interface.
Per full, sorry, Khalid is trying. Oh, someone is asking.
Khalid is already in. Khalid.
I'm already in. Thank you very much, and I'm so sorry about my absence. I have been somewhere else, so sorry, guys.
Okay, no problem, dear. Interface fast Ethernet 0/0, no shutdown. Khalid, in this topology, which router
Yes,
will
sir.
become DR?
1 second.
Yes,
The highest NMID is, which is the 44.
4. But if I will
Yes.
configure OSPF on this router, right? This router will elected as DR. If I will not configure OSPF within 40 seconds on this router. So whenever you will configure OSPF on router will wait for 40 seconds to elect DR and BDR. Only 40 seconds. So if you will configure,
But you can't reload.
yes, sorry.
You can't reload, so will be
Yes,
and it will update.
Okay, exactly. You
Clear
can, if you will
otherwise
reload,
you can write clear IBOSBF process.
yes, exactly what we are doing. So on interface fast Ethernet 0/0, IP address will be 192.168.10.4, 255.255.255.0. After that, router OSPF 1 and network is 192.168.10.0. Wildcard mask will be 0.255 and area is 0. So IP OSPF interface fast Ethernet 0/0. Guys, who is DR? Who is DR? 3.3.3.3. And who is BDR? 2.2.2. Now I want to make this router as DR and this router as BDR. What we need to do? Tell me, Gobind.
Clear our process on all three
We need to
routers,
clear
router 1,
OSPF process on which router?
router 1, 2 and 3.
Why on router 1? Router 1 is DR other now. Router 1 is DR now.
Then
DR
router
other
2 and
now.
router 3.
So once I will run clear IP OSPF process on router 2, which router will become BDR?
R4.
R4 will become BDR. And if I want to make this router as DR, I need to run clear IP OSPF process on R3, right? Okay, so first of all go to R3 and see so IP OSPF interface fast Ethernet 0/0. Who is DR? 3.3.3. Clear IP OSPF process. Now which router will become DR after running this command? Which router will become DR? 4.4.4.4. And which router will become BDR? Now who is my BDR? 2.2.2. So
I
2.2.2.
think when you do when you do clear IP process on R3,
Okay.
router 2 will become DR and the router 4 will become BDR.
No. Now R3 is DR.
Okay.
Now R3 is DR.
When we are clearing R4 on router 3, the BDR should take backup for DR, right?
Exactly. So who is BDR now? This router, right? So this router will become
DR.
DR. C. So IP OSPF interface fast Ethernet 0/0.
Will take, I think, 10 seconds until or unless they send hello.
Yes. After every 10-second router, neighbor router will send hello message. But when you will run clear IP OSPF process on this router, right? This router will send hello message. And whenever router will receive hello message, this router will receive hello message. This one is first hello message, right? After running clear IP OSPF process. Now this router is not their neighbor. This router is not neighbor of R2. So in that time, this router will send trigger hello. Right? It will not send periodic. After sending one trigger hello message, it will send periodic hello message after every 10 seconds. So whenever a router will receive hello message first time from a router, right? That router will send a trigger hello message, right? Hello message can be sent as a trigger as well and as a periodic as well. Okay. Now which router is DR?
2.
Router 2 is DR. And who is BDR? 4.4.4. Now if I will run clear IP OSPF process on R2, which router will become BDR?
R4.
Clear IP OSPF process. Yes. So IP OSPF interface fast Ethernet 0/0. Who is DR now? 4.4.4. Who is BDR now? 3.3.3. Now it's fine, right? Now this router is DR and this router is BDR. Let me capture this link. Guys, let me open any message. Who is sending this hello message?
Router 2.
Router 2. On which address?
5.
On 224.0.0.5. Is there any update message? No. Let me shut down the loopback of R2 and let me run no shutdown command again. So on R2, interface loopback 1 shutdown, and before run this command, let me capture this link as well. Okay, now go to R2 shutdown and no shutdown. Where is my Wireshark? Yes, here. See, who is sending this update message?
Router 2.
On which address?
Row 6.
There is information about which network?
Loopback.
2.2.2.2, right? And DR router will send the information of this network to DR other also, to R1
DR.
also. Who is sending?
Router 2.
Oh my god. DR other is sending to DR other. No. On which address? Address is 224.0.0.6. So DR other is not member of this multicast group. So this router will not accept this update. Okay, let me check next update. So this one. Who is sending? DR. On which address?
.5.
.5 and C. There is information of 2.2.2.2. And who is advertising this network? A router whose router ID is 2.2.2. Who is sending 4.4.4.4? Means DR is sending to DR other, and DR is telling to DR other that this is not my network, this is not my link, this is link of 2.2.2.2. Am I right? What is happening? Whenever this network will come up, what this router will do? This router will send a update on which address? 2.0.0. On which address?
6. It is sending to DR, so it will reach .6.
Yes. So it will send on .6. Right? So this router will also receive this update message, right? But this interface is not member of this multicast group. So this router will simply discard it. Am I right? This router will simply discard it. What this router will do?
Only DR and BDR will accept.
Yes, only DR and BDR will accept. But what BDR will do? BDR will not do anything, right? BDR will simply update their database, right? BDR will update their database. Guys, BDR have information, but BDR will send only when DR will goes down, right? And what DR is doing? DR is sending the same update on what address? On 224.0.0.5. Now this update will receive by this router also, this router also, and this router also. So in that update there will be sequence number as well, right? So suppose when R2 will send the information of this network to DR and R1 is sending with sequence number 5, just suppose. So when DR will send the same update on this multicast address with sequence number 5, when this router will receive that update, it will check sequence number. So sequence number is 5. I have already this LSA. I have already the information of this LSA with sequence number 5. So this router will not accept. What this router will do? This router will check their database. In their database, there will be LSA of 2.2.2 with sequence number 4. And now I am receiving the same information of 2.2.2 with sequence number 5. So now I should update my database, and it will accept and it will update their database, and this router will run SPF algorithm on their database and find shortest path to reach in this network. Fine. Guys, any dot till now in DR and BDR? DR and BDR is very important topic in OSPF. Any dot? Is it clear to everyone? Highest router with highest router ID will become DR, right? DR will send update on 224.0.0.5 and DR other will send update on 0.0.6,
And the DR BDR selection is being used just to stop flooding of LSA within an area, right?
Yes, exactly. Whenever my network type is multi-access network, in that time there will be flooding of LSA1. So to reduce that LSA1, we have concept of DR and BDR. Fine. Now my topic is types of router in OSPF. So guys, we have 4 types of router in OSPF. Number 1, backbone router. Second one is internal router. Third one is ABR router. And fourth one is ASBR router. In last class we had discussed 2 types of area in OSPF, right? Backbone area and regular area. Backbone area means area 0, and regular area means any area except area 0. It can be area 1, it can be area 2, it can be area 3, it can be area 4, any area except area 0. Now we have some types of router. First one is backbone router. What do you mean by backbone router? Router whose all interface belongs to area 0. A router whose all interface belongs to area 0. In my scenario, in my network, you can see. Okay, let me remove it. See, this interface is advertised in area 0, and this loopback interface is also advertised in area 0. So all interface of this router belongs to area 0. So this router is an backbone router. In the same way, this router is also backbone router, this one is also backbone router, and this one is also backbone router, right? Then what is internal router?
Router within any regular area.
Router
within
whose all
regular
interface interface belongs to
regular
area, right? Suppose I have a router R1 with 4 interface, 0/0, 0/1, 1/0, and 1/1. And if I will advertise all interface in area 1, then this router will consider as internal router. This router will consider as internal router. And suppose in this topology, if I have one more router R5, right, and R5 is connected with R4 through fast Ethernet 0/1, this one is 0/0, and if I will run OSPF area 1 over here, I will advertise this interface in area 1, and I will advertise this interface in area 1 also, right? If I will advertise this interface in area 0, guys, neighborship will not form between R4 and R5, right? Remember, area ID must match, right? What information will go in hello message? There will be information about area ID as well, right, in hello message, and area ID must match to become neighbor, right? In last class we had discussed. So see, let me talk about this router, about R4. One interface is present in area 0 and one interface is present in area. This interface is present in area 0, this interface is present in area 0, and this interface present in area 1. So router whose at least one interface belongs to regular area and at least one interface belongs to area 0, that type of router is called ABR router. Okay, router whose at least one interface belongs to any regular area and one interface belongs to area 0, that router will become ABR router. ABR stands for area border router. You can see this router is acting as area border because this is my area 1 and this is area 0. So this router is an area border router. Okay. Khalid, is it clear to you?
100%, yes.
Firaz, am I audible to you, dear? Badnath, Satyendra, what about you guys?
Yes, clear.
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 Okay, Satyendra, you tell me what is ABR? What is area border router? If interviewer will ask you to explain ABR router in OSPF, what will be your answer? Satyendra.
Yes, sir.
What is ABR router? Govind, can you explain?
ABR router which has at least one interface advertised in area 0 and other one in
Okay. Okay, so see, suppose I am designing one network. This is my R1, this is my R2, this is my R3, this is my R4, this is my R5, this is my R6, this is my R7. Here I am running EIGRP. Okay. Here I am running OSPF area 1. And here I am running OSPF area 0. Now, which router is backbone router? How many backbone router are there?
2.
Which one, dear?
R1, R2.
Yes, R1 and R2, because all interface of R1 and R2 belongs to area 0. Okay, which router will become ABR, area border router?
R3.
R3.
R3, yes, because 2 interface of R3 belongs to area 0 and 2 interface of R3 belongs to area 1. So this router will become ABR, right? And the router whose at least one interface belongs to OSPF domain and at least one interface belongs to any other routing protocol domain, in any other domain, right? Either I am running EIGRP or RIP or static routing. Static routing, right? So router whose at least one interface belongs to OSPF domain and one interface belongs to any other domain, that router will be called as ASBR, ASBR, autonomous system border router, right? Autonomous system border router. Is it clear to everyone? 4 type of router: backbone router whose all interface belongs to area 0, internal router whose all interface belongs to regular area, ABR router whose at least one interface belongs to area 0 and at least one interface belongs to any regular area, right? And router whose one interface belongs to any in OSPF and one interface belongs to any other domain, that router will elected as ASBR router. Is it clear? 4 types of
If
router in OSPF.
router 4 is part of area 0 also. In
Router
that condition also will this
No, this
be
is
ASBR?
see, this interface belongs to OSPF domain. Am I right?
Yes.
And this interface belongs to EIGRP domain.
Okay.
So a router whose one interface belongs to OSPF domain, and
No matter
suppose
what
here
the area ID is.
and suppose here is one more router, and here I am running RIP, right? Here I am running BGP. Doesn't matter whose one interface belongs to any other domain, and one interface is present in OSPF domain. That router will elect as ASBR router.
So this is the one who is
Sir.
responsible for redistribution.
Yes,
Sir,
yes, yes.
in this case, R6 and R7 are also internal router.
These routers are not member of OSPF. I am not running OSPF. See, this is types of router in OSPF only. I am talking about types of router in OSPF, right? Here you are not running OSPF on R6 and on R7. This router R5
So
will
what
also elected as ASBR. So there are 2
So
ASBR.
R4,
Yes, Khalid.
one second. So R4 and R5, we say that they are
ASBR.
ASBR.
Yes,
But R6 and R7,
yes.
which type of router are?
They are internal to other protocols like EIGRP or RIP.
Exactly, yeah, that's why I was trying to say.
So you are not running OSPF on these 2 router. So these router will not elected as backbone router or internal router or ABR router and ASBR router. Here you are not running EIGRP. Here you are not running, OSPF. This is EIGRP router. This one is also EIGRP router.
So EIGRP router, they don't have this classification of internal and...
No, in EIGRP, there are no types of router here. There are no types of
Okay,
router.
exactly. Okay, perfect. Now you are very clear.
Okay.
Yes.
Is it clear to everyone? 4 types of router in OSPF? Yes? Now,
One second.
yes.
Technically speaking, when we say AS, autonomous system, is for example, when we configure EGRB, or we need to configure as AS number. So this configuration is different. Is just only operator.
Yes.
For example, Vodafone or something like that.
Can you ask your question again, Khalid?
When we say AS number,
AS number, autonomous system number.
is a number which is given.
It is not a
A
number, it
different
is
operator.
a domain. It is an area. AS number is used to identify this domain. See, suppose I have 2 router, R1 and R2, and I am running AS number 10 over here and AS number 10 over here, right? So this router and this router belongs to same domain, right? This AS number is telling you that both router are belongs to same domain. So routing policy for this router will be same.
Okay, clear. Thank you.
Basically, it is a domain identifier where all the routers share the same routing policies.
Yes. Suppose you are living in a society. Fine. Khalid is living in a society, and name of the society is, suppose name of the society is CCNA. Okay. Name of your society is CCNA. So how someone will identify you that where you are living? By this name. That means there is one domain, and name of that domain is CCNA, and if there is Gobind also, Gobind. So how we identify that Gobind and Khalid is living in same society? If I will ask to Khalid, where are you living? Then Khalid will say in CCNA. In CCNA society, then I will ask to Gobind also. Gobind will say in CCNA society. So, domain AS, the name which you are using to identify area is same, right? That means Gobind and Khalid is living in same society. So light bill, water supply bill, everything will be same for these two person, right? In the same way, if we have two router R1 and R2, if I am running AS number 10 over here and AS number 10 over here, right? So when I will ask to R1, in which domain you are living, R1 will tell to me that I am living in AS10, and R2 will also tell to me that I am living in AS10. Okay, then I will came to know that routing policy for these two router will be same. And if I have two router R1 and R2 and I am running AS10 over here and 20 over here, if I will ask to R1, where are you living? R1 will tell that I am living in AS10, and R2 will tell to me that I am living in AS20. Then I came to know both router are living in different domain. So routing policy for these two router will be different. Okay. If I will ask to Khalid that where are you living, if Khalid will say in CCNA, and if I will ask to Gobind, Gobind will say in CCNP. That means light bill, water supply bill, rule and regulation, right, of Khalid and Gobind will be different. Am I right, Khalid?
You are more than clear.
Clear?
You can't be more than clear. 100%. Yeah, thank you.
Okay. Now, guys, last topic is LSA. LSA stands for Link State Advertisement. OSPF router will not send routing table with their neighbor. What OSPF router will share with their neighbor? That is LSA. If you will check the database of router, let me show you the database of R1. Here you can see the database of R1. Let me maximize it. So IP OSPF database. So see the database of R1. Guys, these are LSA. These are LSA. These are also LSA. So you can see here is one network LSA, and there are 1, 2, 3, 4 router LSA. This one is router LSA. What will be the information in database of OSPF router? There will be LSA. There will be LSA. Can this router design complete topology by checking their database? Yes or no?
Yes.
How? What this router will check first?
Router ID.
Router ID of?
Whole LSA.
Okay, my router ID is 1.1.1.
And I will check database for 1.1.1.
My router ID is 1.1.1.1. Then what this router will check? R1 will check. Then what R1 will check? Their database. So IP OSPF database. So this is database of my. This is database of 1.1.1.1. First of all, this router will open their own database in detail. What will be the command? So IP OSPF database router 1.1.1.1. This is detailed information of this database of 1.1.1.1, right? See, a link is connected to a stub network. A stub network means directly connected network. Means there is one directly connected network. and network is 1.1.1.1. Subnet mask of this network is /32. Am I right? And metric for this network is 1. And there is one more network, that is 192.168. Oh, there is information about designated router, about DR. So there is one router who is DR 192.168.10.4. And what is the IP address of my interface, which is connected to DR? 192.168.10.1 means IP address of my interface is 192.168.10.1. Am I right? And cost of this link is 1. Gobind, tell me what R1 will check now.
For the database of 2.2.2.
First of all, it will check their database, so IP OSPF database, and there is LSA of 2.2.2.2. So it will open the database of 2.2.2 in detail. So IP OSPF database 2.2.2.2. So IP OSPF database router 2.2.2.2. So a router with router ID 2.2.2, and there is one stub network, that is 2.2.2.2, and transit network means directly connected network. Transit network means the network which is connected with me. Network which is connected with me. And stub network means network which is connected with 2.2.2.2. Either it can be a LAN network or it can be a loopback. Right? So R1 can design a topology. So this somewhere is one router R2 whose router ID is 2.2.2.2. Right? And there is one stub network, that is 2.2.2.2, and there is one transit network, that is 192.168.10.2. Then this router will check their database again. So IP OSPF database, and there is database of 3.3.3.3. Now this router will open the database of 3.3.3 in detail. So somewhere there is one router. Router ID of this router is 3.3.3.3. There is one stub network, that is 3.3.3.3. Am I right? Subnet mask is this one, and transit network is 192.168.10.3. Then this router will check their database again. So IP OSPF database, there is one mode database, mode LSA 4.4.4. So IP OSPF database router 4.4.4.4. So there is one router R4, and router ID of this router is 4.4.4.4. Right? There is one stub network. No stub network are there. So IP OSPF
I think you did shut down one interview.
Okay, loopback is shut down. Okay. So here we are running what IP address? 192.168.10.4, and these are connected through a switch. So you can see R1 can design complete topology by checking their database. So a router will have complete information about topology. This is how OSPF routing protocol is different from EIGRP and RIP, from distance vector routing protocol, right? Now guys, we have some type of LSA. LSA 1, LSA 2, LSA 3, LSA 4, LSA 5. In CCNA, LSA 1 and LSA 2, LSA 3 is more than sufficient. By the way, LSA is not a part of CCNA, but many time interviewer is asking to network engineer, what is the use of LSA 1, what is the use of LSA 2, what is the use of LSA 3. LSA 1 is, always keep in mind that every router within an area will generate LSA 1. Every router will generate LSA 1. LSA 1 is router LSA. What we called it? Router LSA. LSA 2 is, okay, lib LSA 2. For some time, let me talk about LSA 3. LSA 3 is network LSA. So what is the use of LSA 1? LSA 1 is used to share the information about link, and every router within area will generate LSA 1. And always remember, LSA 1 will never cross area. LSA 1 will never cross area. Suppose I have some router R1, R2, R3, R4, R5, R6. This is my area 1 and this is my area 0. How many LSA will be there in area 0? LSA 1, I am talking about LSA 1. How many LSA 1 will be there in this area? 4. 1 LSA of R1, 1 LSA of R2, 1 LSA of R3 and 1 LSA of R4. And how many LSA 1 will be there in this area? There will be 4 LSA 1. But guys, LSA 1 will never cross area. Right? It will not cross area. LSA 1 can't cross area. Always keep in mind. Then how communication will happen between area 0 and area 1? With the help of ABR. With the help of ABR. This router is ABR because one interface is present in area 0 and one interface is present in area 1. One interface belongs to backbone area and one interface belongs to regular area. So this router will become ABR router and this router will also become ABR router, right? So what ABR router will do? ABR router will share the routing table of area 1 in area 0. Routing table of all the prefixes of area 0. It will not send LSA 1 in this area. So this router, if I talk about R1 don't know anything about R3, about this router. A router have complete information about topology within area. Between area, OSPF will work as distance vector routing protocol. The router which is present in area 1, they don't know anything about the router which is present in area 0. But there is all prefix of area 0 in area 1, right? in this area there will be all network. Suppose here is one network, 1.1.1.1. so ABR router will send 1.1.1.1 in area 1, but this router will not send LSA 1. LSA 1 will never cross area. What is the use of LSA 2? What is the use of LSA 2? LSA 2 is used, LSA 2, DR router will use LSA 2. DR router will use LSA 2 to inform see in my topology in the database of R1, so IP OSPF database. Guys, how many LSA are there? How many types of LSA are there? There are two types of LSA. First one is router LSA, router link state LSA, and there is one network LSA. And you can see who is sending network LSA. Who is sending network LSA? DR router, right? So if in my network there is no DR, then there will be no LSA, network LSA, then there will be no network LSA. If I will open this LSA, network LSA, what is the information are there? What will be the information in network LSA? Router OSPF, database and network. Oh, there is information about attached router. That means DR router will send network LSA to all DR other router, right? And DR router will tell to this router that how many router are attached in this multi-segment network. How many router are connected in this multi-segment network. So always keep in mind, network LSA is not used to share the information of link. The network LSA is not used to share the information of network. Am I right? Network LSA is used by DR router to tell to their neighbor about the router which is connected in multi-access segment. Suppose I have two router which is connected through, suppose we have two router R1 and R2, and if I will connect point to point, now my network type is point to point. Do you think that there will be in the database of this router, in the database of R5, there will be network LSA? Do you think that in the database of R5 there will be network LSA? Guys, there will be no network LSA. You can see. Configure terminal interface serial 2/0 no shutdown. IP address is 10.0.0.125.0.0.0. Router OSPF 1 and network 10.0.0.0.0.0.255 and area is 0 and router ID is 1.1.1.1. Go to this router. see the database of this router. There are only router LSA. There are only LSA 1. There is only LSA 1. So network LSA will generated by DR router only. Network LSA will generated by DR router only, right? And LSA 3 will generated by ABR router. LSA 3 will generate by ABR, LSA 1, LSA 2, LSA 3, LSA 4. LSA 1, every router within area will generate LSA 1, right? And LSA 1 will flood within area. LSA 2 will generated by DR router. LSA 3 will generated by ABR router, right? ABR router will share the prefixes of different area in different area. ABR router will make communication possible between two different area by sending the route through LSA 3. So always remember LSA 1, LSA 3, LSA 5, LSA 7, LSA 9, all the LSA, odd LSA is used to share information of network. And LSA 2, LSA 4, LSA 6, these LSA will not use to share the information of network, right? LSA 2 is used by DR to tell all the router about directly connected, or how many router are directly connected in this segment, in this network. Fine. LSA 4 will used by ABR. Now LSA 4 will used by ABR. That ABR will tell to all the router in area that this router will see in my topology. Suppose इसमें R1, इसमें R2, इसमें R3, इसमें R4. Suppose इसमें R6, इसमें R7. This is area 0 and area 1. Guys, who will tell to R1 that R3 is ABR? ABR router will tell to R1, R2, R6 and R7 that 3.3.3.3 is your ABR. By which LSA? By LSA 4. By E1 LSA. LSA 1 and LSA 3 is used to share the information of network, and LSA 2 and LSA 4 is not used to share the information of